On October 29th, 2025, the oddball object labeled 3I Atlas, the third confirmed interstellar visitor to pass through our neighborhood, reached perihelion, its closest approach to the Sun. At that moment, the object sat roughly 136 astronomical units from the Sun. An astronomical unit, or AU, is the average Earth. Sun distance? Well outside Mercury and Venus, but inside the orbit of Mars. Telescopes and the spacecraft watched. But because perihelion occurs on the far side of the Sun for many ground observers, the event was effectively hidden from casual view. The perihelion marks a pivotal checkpoint. The Sun does to a passing body what gravity and heat do to almost anything that dares cross the inner system. It tests structure, composition, and, if the object were somehow capable of powered motion, intent. That simple date and distance matter because perihelion is where an object can gain, or shed, the most energy. If 3I Atlas is a natural interstellar comet or rocky fragment, perihelion can crack it open, ignite outgassing, or otherwise reveal its chemistry under intense solar heating. If, instead, it carries something engineered or powered, perihelion is also the place where a deliberately timed impulse could produce the largest change in trajectory for the smallest fuel expenditure. That idea, an Oberth Maneuver executed at perihelion, is the core of the more exotic, but physically plausible, scenarios people are discussing. 3 basic futures, from ordinary to extraordinary, boiled down to 3 scenarios. Here's what could happen next. 1. The baseline. It behaves like an oddball comet and continues its unmodified hyperbolic course. This is by far the simplest explanation and the default scientific expectation. Many interstellar visitors have been revealed as unusual but natural bodies. Once astronomers took spectra, imaged convey, and measured trajectories. If 3I Atlas simply continues outward on its hyperbolic path, the story will still be fascinating. Observers will watch how the coma evolves after perihelion, measure its chemistry and dust, and compare it to Oumuamua and 2I Borisov. NASA and mainstream planet science teams emphasize this non-threat assessment. Observational data so far place the object on a one-time passage that keeps it safely far from Earth. 2. The extreme but physically possible. A deliberate Oberth-like maneuver that redirects toward the inner system, even Earth. An Oberth maneuver uses the kinetic energy gained from falling deep into a gravity well to amplify the effect of a rocket burn. In principle, a relatively modest impulse applied near perihelion can produce a far larger change in heliocentric energy than the same impulse applied far from the Sun. That's why human mission planners send probes close to planets or the Sun to get the most bang for the buck. If 3I Atlas were more than a passive rock, if it had propulsion or was an engineered vehicle, timing a burn at perihelion could alter its outbound path dramatically. In practice, however, redirecting an object from its incoming hyperbolic trajectory onto a course to intersect Earth is technically demanding. It requires a large negative velocity change, a significant reverse thrust, timed precisely while observations are limited by the Sun's glare. As a result, any such Earth-directed conversion would not be trivial and would likely show up in weeks of follow-up tracking once the object re-emerges from behind the Sun. Avi Loeb and others have written publicly about the perihelion acid test and the idea that perihelion is where one could quickly tell natural from anomalous behavior. If the object suddenly fragments, brightens, or shows an unexpected change in orbit. 3. The middle ground. A small, purposeful adjustment that nudges the outbound path toward Jupiter and its moons. If a hypothetical operator wanted to use the solar Oberth for long-range trajectory control, but had objectives farther out in the giant planet zone, redirecting toward Jupiter makes a lot of sense. Jupiter is the solar system's heavyweight, It dominates local gravity and hosts large moons: Ganymede, Callisto, Europa. That are the most obvious candidates for follow-up study, refuge, or resource exploitation. A modest perihelion burn could alter the trajectory enough to set the object on a Jupiter encounter path. From a practical standpoint, sending small probes or attempting to park near Jovian moons requires less delta-v than steering all the way to Earth from an incoming hyperbolic leg, and the geometry for such a transfer can be achieved with comparatively smaller energy if the timing is right. Observers have noted that on the outbound leg, 3O Atlas's trajectory brings it into the neighborhood of Jupiter's orbit, meaning a small change at perihelion could make Jupiter accessible. What the numbers actually say, concrete dates and distances anchor these scenarios in reality. The perihelion on October 29th, 2025 occurred at about 136 AU from the Sun. After perihelion, predictive orbit models place 3I Atlas at a closest Earth approach on December 19th, 2025 at roughly 1.8 AU, about 269 million kilometers. A safe, comfortable distance by planetary defense metrics. Models also show a later geometry where, on its outbound leg, the object could come within tens of millions of kilometers of Jupiter. Numbers in public tracking feeds indicate flyby distances on the order of 54 million kilometers for a Jupiter encounter, depending on whether any perihelion impulse occurred. These raw figures are critical. They frame what is and isn't feasible if anyone or anything wanted to change course. Why early January 2026 looms large, even if 3I Atlas does nothing dramatic at perihelion. The early weeks of 2026 present an unusual gravitational geometry worth watching. From January 4th, 2026, with January 9th often highlighted in visualizations. Multiple inner solar system bodies: Mercury, Venus, Earth, Mars, and Jupiter as a heavyweight fall into a relatively compact configuration along the ecliptic from our vantage. Alone, that doesn't mean disaster. Planetary parades happen often enough that sensational claims are easy to manufacture. But the particular coincidence that 3I Atlas's inbound vector traces back to the constellation Sagittarius adds an extra narrative layer. Sagittarius is roughly in the direction of the galactic center, and that's where sky surveys traced the object's incoming path. So the same vector direction that produced the object's detection earlier in 2025 roughly lines up with the January geometry. That alignment makes the collective gravitational vectors, the orbital resonances, and even the heliospheric electromagnetic configuration slightly different than they would otherwise be. It's the kind of configuration that raises questions worth asking. Does the cumulative geometry tweak space weather, tidal forcing on small bodies, or observational opportunities? The short answer, perhaps a hair's breadth, but not a catastrophe. And crucially, it's observable and testable. Sky map and simulation tools used by observers, the same sorts of visualizers you can open on public pages, show 3I Atlas sitting near the ecliptic during those early January days. If the object survives perihelion intact and unpowered, it will be participating in that planetary geometry purely by virtue of orbital mechanics. If instead it executes a small perihelion burn, that burn will be amplified by the Sun's gravitational well and could throw the object into a new corridor that intersects the inner or outer planets in the months that follow. Either way, the early January window and the subsequent Jupiter flyby geometry in the spring of 2026 will provide the highest leverage observational moments for distinguishing natural from anomalous outcomes. How you tell natural from engineered observationally. Astronomers will look for 3 types of signals that differentiate a natural comet from a powered object: photometric changes, sudden increases in brightness or fragmentation at perihelion suggest volatile breakup, or classic comet behavior. Conversely, a lack of expected coma evolution or light signatures inconsistent with dust, gas scattering would be anomalous. Trajectory deviations, small but statistically significant non-gravitational accelerations, especially right after perihelion, could indicate outgassing, natural, or, in rarer circumstances, thrusting, engineered. Repeated, independent astrometry from multiple observatories is the way to detect these spectral chemical fingerprints. Radio and optical spectroscopy will reveal the mix of ices, minerals, and molecular species. Some reported measurements earlier in 2025 indicated unusual polarization and compositional hints that made Atlas stand out. More data post-perihelion will help scientists decide how exotic its chemistry really is. In public conversation, the stakes of these measurements are sometimes overstated. An unusual chemical signature is not evidence of technology, nor is an anomalous acceleration immediate proof of intent. Science proceeds by eliminating natural explanations first, and the community has a long-established workflow. Independent astrometry, spectroscopy, and radar, where possible, for doing precisely that. Historical context, alignments, and solar storms. The human tendency is to map meaning onto rare celestial geometry. There is precedent for dramatic solar-terrestrial interaction. The Carrington event of 1859, for example, was an extreme geomagnetic storm that produced aurora visible at tropical latitudes and disrupted telegraph systems. But the link between a planetary alignment and a solar storm is subtle. The sun's activity is driven by internal magnetic dynamics over months and years, while planetary positions are external geometry. Occasionally, people find suggestive geometry near known historical storms. But correlation is not causation. The correct scientific approach is to monitor solar activity, sunspots, coronal mass ejections, radio flux, and compare to the object's timing. We have the instrumentation to do just that. The really important point is that monitoring and data collection, not armchair pattern matching, will separate signal from myth, what the agencies say, and why no threat matters. Public-facing agencies are blunt. Current orbit solutions put the object on a trajectory that does not intersect Earth, and no credible evidence points to an imminent impact or energetic threat. That assessment matters because it frames how scientific resources are allocated. Telescopes, radar time, and spacecraft assets are expensive. They're deployed in order of scientific or practical priority. The perihelion window and the January March geometry are high-value intervals for follow-up observations, but they are not reasons to expect imminent danger. At present, both NASA and independent tracking services present a consistent picture. Interesting object, unusual in places, but not a planetary strike risk. Where the real unknowns are, and how we'll resolve them. The honest truth is that the most interesting aspect of 3i Atlas is how it pushes the limits of what we can learn from a one-shot visitor. Here are the real unknowns that will determine the story over the next 12 months. Does perihelion change its physical state? Breakup, brightening, or an unexpected light curve would be the most direct evidence of something unusual happening during the thermal stress of passing the sun. Do precise astrometry solutions show non-gravitational effects? If later tracking gives residuals that systematic gravity can't explain, astronomers will test models of outgassing and then, only after natural models fail, entertain engineered propulsion hypotheses. Will 3i Atlas come close enough to Jupiter or its moons for follow-ups? A Jupiter flyby, even at tens of millions of kilometers, could enable radio surveillance by orbiters like Juno or ground-based observers to study induced radio emissions. If the object's post-perihelion trajectory nudges it closer to Jupiter than current models indicate, that's a high-priority scientific event. These unknowns are resolvable. The tools exist: optical telescopes, large radio dishes, spaceborne coronagraphs that saw portions of the object earlier, and teams around the world poised to take astrometric and spectroscopic data. What we need is patience and careful interpretation. A final, practical note for watchers. If you're following this story, there are 3 practical behaviors that are helpful and healthy. Follow the professional sources. Look to NASA, professional journals, and reputable science outlets for updates. These organizations publish orbit solutions, uncertainties, and supporting data. Expect ambiguity. Demand data. Unusual observations almost always have natural explanations after careful analysis. Don't let early mystery be a substitute for measurement. Observe, but don't panic. The numbers. Perihelion distance, December closest approach to Earth at 1.8 AEU, and the likely Jupiter geometry. All point to scientific opportunity, not danger. What makes this object special is not the threat it poses, but the questions it forces astronomers to answer. 3i Atlas may turn out to be a curious but ultimately natural visitor. Or it may surprise us in subtle ways that deepen the puzzle. Either outcome is a win for science. Perihelion provided the stress test. Now the early 2026 geometry and the coming months of coordinated observation will do the heavy lifting. We will know more by looking and by letting the data decide.